Right, so let's get this started. We stopped on this question yesterday. We can just quickly review this. Which form of a quadratic are these equations in?
Factored?
Yeah, so A, B, and C is in factored. D is also kind of in unfactored form because you can rewrite D as, again, it says squared. That means it's being multiplied by itself. So D, if you wanted to, you could write it in factored form like this. D is also in the vertex form because the vertex form has this A x plus h squared, or it's x minus h squared plus k. This is the vertex form. So the vertex here would be -4 and 0, okay?
Mm-hmm.
-4 and 0. So let's just quickly do some of these. I guess we did A and B yesterday. We can do C. It says finding the zeros. Zeros super simple. If you have the thingamajig in factored form, to find the zeros, you just flip the signs. Not always the case. For example, if you have something like 2x minus 1 and 5x plus 6, the x-intercept will be 1 over 2 for this, because we're setting it equal to 0 and solving it. And then for this, the x-intercept would be subtract 6 divided by 5, -6 over 5. Okay?
Mm-hmm.
If there are coefficients here, you need to kind of solve for it. But if there's no coefficient here, like for all of these questions, you can straight up flip them. So for C, the x-intercepts or the zeros will be 1 and -3. To find the y-intercept, what you do is you set x equal to 0. So for C, to find the y-intercept, you just set the x is equal to 0. You'll see that it becomes 2 times -1 times +3. That's -2 times 3, that's -6. That's the y-intercept. And to find the h value of the vertex, you find the midpoint of the x-intercepts. So you get -2 over 2, you get -1. How do you find the y value of the vertex? You want to plug it back into the equation, yeah?
Mm-hmm.
If you have the h, which is the x value of the vertex, it's also the axis of symmetry. To find the y value of the vertex, straight up plug that x value, or plug this h value as x back into the equation. So it's going to look like this: 2 times -1 minus 1 times -1 plus 3. So this is 2 times -2 times +2. That will be -8. So there you go. If you want to graph it, we can quickly graph it. It's 1 and -3 are the x-intercepts. -1 is the axis of symmetry, or the x value of the vertex. You have -6 as your y-intercept. And we know our vertex is at -1 and -8. So let's say that point down there is -8. And then we just connect all the dots. This is a parabola that opens upwards because the a value is positive. And then you connect all the dots: x-intercepts, vertex, y-intercept. And this is it, just like that. What about D? What's the x-intercept of D? See, look at this equation. What's the x-intercept? Just flip the sign. We have x
Negative.
plus, yeah, it's -4, right?
Mm-hmm.
It is -4. And it's a repeated root. That means at -4, there's going to be a turning point. So 0 is -4. The y-intercept, you need to set the x as 0. So it's going to be -0.5 times 16. It'll be -8. To find the y value, sorry, to find the x value of the vertex, if you can see that this is in the vertex form, then you can straight up say it's -4. But if you don't see it, what you can do is you can do what we've been doing all along. Just find the midpoint of the x-intercepts. In this case, both the x-intercepts are -4, so -4 minus -4 over 2 will still be -4. Plug this back into the equation, you'll get -0.5 times a 0 squared, you'll get 0. So that's your vertex, okay?
Mm-hmm.
Here, look at this. The vertex form of a quadratic is in this form. Y equals a, x minus h squared plus k. So if I give you something like this, let me use a different number here. What is h and what is k? Compare these two equations. We know a is -3. What is h and what is k? See,
H is 4.
h is -4 or +4?
Positive.
Yeah, h is positive. What about k?
-5.
-5. So there you go. That's your vertex, okay? Vertex, if you have x minus something squared like this, then you're adding or subtracting a number. Anything that's in this form is in the vertex form. Let's find the x-intercepts, because now it's more difficult to find x-intercepts because it's not in the factored form. Now the question is, given this equation, which we know is in vertex form, how do you find the x-intercepts? To find x-intercept of any equation, doesn't matter what it is, right? Anything ever, you're going to set y equals to 0. Same thing as finding the y-intercept. To find the y-intercept, doesn't matter what the equation is or the function, you're going to set x equal to 0. So look at this. This becomes a 0 is equals to -3 x minus 4 squared minus 5. How do you solve this equation for x? Step 1, move the 5. Okay?
Mm-hmm. You add 5.
Yeah, you add 5 on both sides. So this becomes 5 is equals to -3 x minus 4 squared. Now what? We're trying to solve for x.
Are you supposed to open the brackets?
No. If you do open the bracket, you're gonna get a quadratic in its standard form, and then you would have to man it, which in most cases, sometimes it's possible, sometimes it's not. It's more like a 50-50. Do not open the brackets. Get rid of the -3. So divide both sides by -3, okay?
Mm-hmm.
And then you get this. Do not open the bracket. We need to get rid of the squared. What do you do on both sides?
Square root.
Square root, right? What I'm going to tell you now, at this level, whenever you square root something, you're going to get two different answers. One of them will be positive, the other one will be negative, okay? So this
Mm-hmm.
is what it turns out. Whenever you take a square root, it's going to be plus, minus. Can you take a square root of 5 over -3, which will be like -1.66? Can we root that? Can we square root a negative number?
You can't.
You can't, right? So for our purposes, what that means is that this equation that we have in its whatever form, the vertex form, this does not go through the x-axis, okay? We can kind of
Mm-hmm.
show this as well because this is a parabola that opens downwards that has a vertex at +4 and -5. So here's the vertex, right? And the y-intercept, to find the y-intercept, just get rid of this or set x as 0. So it'll be negative 3 times 16 minus 5. That's negative 48 minus 5. That's negative 53. So negative 53 is our y-intercept, yeah? And look at the curve. We know this is opening downwards because the a value of negative 3 is negative. It's going to go through here. It's going to go through the vertex, and it's going to come back down. You see, it never goes through the x-axis. That's what this tells us as well. You are trying to take a square root of a negative number, yeah? It's
Mm-hmm.
not possible. Well, it's not possible in the real number system, but that's what grade 10 is all about. Maybe in grade 11, you're going to see the other system, which is complex numbers. There you can take the square root of negative number, but for this course at grade 10 level, we can't take a square root of a negative number, okay? Because we use the real number system. Here they've given us the zeros, which means the x-intercepts. And we know the y-intercept as well. It crosses the y-axis at 50. That means that is the y-intercept. Which form of the quadratic should we use here? It's asking us to come up with an equation. They've given us zeros, remember that. Which form is easy if they give us 0? You only have 3 choices, right? You have the standard form, which doesn't really use the x-intercept. You have the vertex form, which uses the vertex that we don't have. And the final form is the factored form, which uses the x-intercept. Again, look at this, the 3 forms. Standard form is this, ax squared plus bx plus c. How is this useful? Well, you have the y-intercept. You have the direction of opening. That's all it tells you. This one is most useful when you need to use a quadratic formula, okay?
Mm-hmm.
Quadratic formula, and you can man this if possible. That's where it's useful. The vertex form, a x minus h squared plus k. Again, this tells you the direction of opening, doesn't tell you the x-intercept, doesn't tell you the y-intercept. This one is most useful for the vertex form. And then finally, you have the equation in a factored form. This one is most useful when you have the x-intercepts, where s and t are the x-intercepts, okay? So if they've given us the zeros or the x-intercept, they mean the same thing. Zeros and x-intercept mean the same thing. You want to use the factored form of a quadratic. So all you got to do, look at this. We have a x minus s, x minus t. And we know what our s and t are. S is negative 10, t is 30. Okay, those are our 2 x-intercepts. Just plug them into the equation. What does the first bracket become if you replace s with negative 10?
X plus
Yeah, x plus 10, and the other bracket will be x minus 30, right?
10. Mm-hmm.
But we don't know what the a value is. We need to find the a value. They have given us another piece of information, which is the y-intercept. Y-intercept happens when the x value is 0. So they've actually given us a coordinate of 0, 50, okay? It crosses the y-axis at 50, means it's the y-intercept, and we know, it doesn't matter what the function is, at the y-intercept, the x value will always be 0, okay? Look at this, the x value at the y-intercept will always be 0. So that's a coordinate that they've given us. So what we do is we replace our y and x with this coordinate to find the a value. So y is equals to 50. The a value is what we're looking for. The x value is 0, so it becomes 0 plus 10, 0 minus 30. So this becomes a times 10 times negative 30 equals 50. So that's a times negative 300 equals 50. divide both sides by negative 300. 50 over 300 is 1 over 6. So negative 1 over 6 is your a value. Therefore, the final answer for this question for part A, the equation of the parabola in factored form is negative 1 over 6, x plus 10, x minus 30. Okay, like that. Part B, determine the coordinates of the vertex. Now again, remember, we have the two x-intercepts. How do you find the vertex given the x-intercepts? How do you find h?
You add them and divide them by 2.
Yeah, you add them and you divide them by 2. So you get 30 minus 10, 20 over 2. Your h value is 10. To find the y value of the vertex, which is the k value, you want to plug 10 back into this equation here. So, because that's the only equation we do have. So it becomes 10 plus 10, 20. 10 minus 30, negative 10. So this negative and this negative cancels out. You get 200 over 6, which is 100 over 3. And there you go. That is your vertex, yeah? And the question could ask you to rewrite the equation in the vertex form. So look at this. We're going to use this equation here. A value remains unchanged. Look at this. A value is the one constant between all three forms. It remains unchanged. So if the question asks you to write the equation in a vertex form, a value of negative 1 over 6 stays exactly the same. X, yeah, minus h, we know h is 10, so it becomes x minus 10 squared, and then plus k, so plus 100 over 3. That is the equation in the vertex form, okay? So three forms, standard, vertex, and the factored. Factored form is the most common because they will usually ask you or give you the x-intercepts. Not every single time, but what have they given us in this question? They've given us some information. What do you think they've given us?
The vertex.
They've given us the vertex. What's the coordinate of the vertex?
4, 8.
Negative 4. Negative 4, 8. And where are our x-intercepts? There's two of them that they've given us.
Negative 6 and negative 2.
Yeah. Negative 6 and negative 2. If you want to write that as a coordinate, okay, look at this. I'm going to show you how to write x-intercept as a coordinate. At the x-intercept, the y value is 0. Very simple. So your x-intercepts are negative 6 and 0, yeah? And negative 2 and 0. Those are the coordinates of the x-intercepts. Now this question, they've given us the vertex, they've given us the x-intercept. You can use either approach. I'm going to show you both approaches. The first one, we're going to show you the factored form approach. So remember, factored form, the general equation is this: y equals a, x minus s, x minus t. Again, s and t are redundant, right? Like some books, they will write it x minus r, x minus s. You can even rewrite that as x minus x1, x minus x2, right? These ones, you can replace it with whatever you want to. But in this textbook, it uses s and t, I believe. So we're going to stick with this. Alrighty. To use the factored form, we need the two x-intercepts, which they've given us, right? You see, this is your s, this is your t. Let's plug them into this equation. What do we get for the first bracket?
X plus 6.
Yeah, x plus 6. What about the other bracket?
Plus 2.
Plus 2. Now we need to find the a value. How do you find the a value? we need to plug in another point that we haven't used. We've already used the x-intercepts. Is there anything else we can use?
The vertex.
The vertex, right? So we are going to use that point. 8 is your y value. A is what we're trying to solve for. -4 is the x value. So -4 plus 6, -4 plus 2. So this becomes 8 is equals to A times 2 times -2. So 8 over -4A is -2. Therefore, the equation in the factored form, again, it makes sense that A is negative because the graph is opening downwards. So this will be the final answer in factored form, okay? Now let's say we want to do it in the vertex form because they have given us the vertex. So this approach is also going to work. And these two approaches are independent of one another. You can use either one of them. So the general form of a quadratic in a vertex form is this: A x minus h squared plus k. Plug h and k as -4 and -4 and +8 into this equation. What does it become? Plug h as -4 in here. What does the first bracket become?
X plus -4. Or
Uh,
X plus 4.
yeah, x plus 4, just x plus 4 squared, and your k value is 8, right? And again, we're trying to find a. We can't use the vertex because we already used it. Let's use either one of the x-intercepts. You can use -6, 0 or -2, 0 as your x and y value to solve for a. I'm going to use -2, 0. So y is y is 0, right? The y value is 0. A and the x value there is -2 plus 4 squared plus 8. So you get 0 is equals to -2 plus 4 is +2. Squared becomes 4a plus 8. And subtract 8 divided by 4, a becomes -2. Therefore, the final answer in the vertex form is -2, x plus 4 squared plus 8, okay? And
Mhm.
that's how you can do it using both forms in this question because they've given us the x-intercept and they have also given us the vertex. So both approaches work just fine. Notice the a value is exactly the same. A value is the one constant between all three forms. Give an example of an equation of a quadratic whose vertex and x-intercept occur at the same point. So let's say this is the vertex. It's also the x-intercept, yeah?
Mhm.
So it's just asking us to give an example. So let's say that point there is 3, 0, okay? That's the graph. You can just say y is equals to 3. Doesn't matter that the a value is irrelevant. X minus 3 squared plus 0. That's the equation in the vertex form. And if you want it in, actually they're both going to be the same because if you want the equation in the factored form, it'll be x minus 3 times x minus 3. That's the equation in factored form. Repeated roots means there is a turning point there, okay?
Mhm.
There's an infinite number of answers here for this question. Yeah, because it says give an example, you can come up with anything. The next thing is expanding quadratic expressions. Super simple. We just gotta FOIL it. It's just simple foiling. Show that the equation, this equation that's in the factored form, yeah? And the other equation is in the standard form. So they're asking us to show that these are equal. All you gotta do is FOIL it. I'm gonna start from the factored form. To FOIL it, you need brackets, so you need to start from the factored form. To go from here to here, you FOIL it. To go from a standard form to a factored form, you man it, okay?
Mhm.
So here we can show that these two equations are exactly the same. How do we FOIL? You're going to do x times x, and then you're going to do x times +2. What's x times x?
X squared.
Yeah, x squared. What's x times positive 2?
2x.
2x. So we've dealt with the first thing here. Now we're going to go this way. 4 times x and 4 times 2. What's 4 times x?
4x.
And then the last guy is 4 times 2, which is an 8. So if you have two terms, multiplying two terms, as we do here, x plus 4, x is one term, 4 second term, x is one term, 2 is second term. Two terms times two terms, when you FOIL it, you get 4 terms, okay? And we do have 4 terms here, 1, 2, 3, 4. Next, collect like terms, which in this case is just the x's, these two. So this becomes x squared plus 6x plus 8. And there you go. Those two are identical, okay?
Mm-hmm.
To go from a factored form to the standard form, you FOIL it. To go from the standard form to the factored form, if possible, you man it. This is a very simple concept. We're just going to speed run this. Let's do one more. It says open the brackets or multiply each expression. Remember, anything squared means you're multiplying itself twice. So you have itself multiplying itself like that. Open the bracket. What's the first term? So you go this way for the first term. What's 3x times 3x?
9x squared.
Yeah. What's 3x times negative 5?
Negative 15x.
Yes. What's negative 5 times 3x?
It's the same thing.
It's the same thing, right? And the last term is negative 5 times negative 5, which is positive 25. And then you get 9x squared minus 30x plus 25. Cool?
Mm-hmm.
That's the equation in the thingamajig, in the standard form. Now, going backwards is more difficult actually for this question, because to go backwards, we know we can factor it because this thing is in the factored form. Look at this, this becomes kind of tricky. You're looking for two numbers, a set of numbers. When you multiply them, you get 29 times 9, which is 225. When you add them, you get negative 30. Okay, what are the two numbers? You can cheat actually because we already know what they are.
Negative 15 and negative 15.
Yeah, but what if you didn't have this, right? What if you didn't have it? How do you come up with that? Usually, if the number is big, right? As we have, by big I mean like 200, 100, over 100. You should try square rooting it, okay? The first thing you want to do is use your square rooted. Square root of 225 is 15, okay? So what that
Mm-hmm.
means is it's probably 15 and 15. Well, we know it needs to add up to negative 30, so it's going to be negative 15, negative 15. Going back is sometimes more difficult than going forwards. Here it says determine the equation in standard form. What have they given us?
The x-intercepts.
Yeah, they've given us the x-intercepts. So our x-intercepts are negative 4 and 2. This is your S, this is your T, okay? If they've given us the x-intercept, they've also given us the y-intercept, which is 0, 4. If they've given us the x-intercept, which form of the quadratic equation is best?
Factored.
Factored form, right? The general form of a factored quadratic is A x minus s, x minus t. Straight up plug s and t in there. What do you get?
X plus 4
Yeah,
and X minus 2.
right. And then we need to find the a value. Always find the a value before you start expanding. To find the a value, we're going to use the y-intercept. The y value is 4 when the x value is 0. Are we expecting a positive a value or a negative a value? Look at the graph.
Negative.
Negative, and we do get a negative because 4 over negative 8 is negative 1 over 2. Therefore, the equation in factored form is negative 1 over 2, x plus 4, x minus 2, okay? Now it's
Mhm.
asking us to find the equation in standard form. To get to standard form from any form, you just open the brackets. So you can do this multiple ways. You can either do a, so we have 3 terms here. We have this guy, and this guy. So we can call them A, B, C. When you have a triplet, you can either do AB first and then multiply that by C, or you can do BC first and multiply that by an A. In this case, the A is a fraction, so I'm going to leave it till the end. So we're going to leave this 1 over 2 till the end. Let's open these 2 brackets. What's the first term?
X squared.
Yeah, x squared. What's the second term?
Negative 2x.
What's the third term?
4x.
What's the last term?
Negative 8.
Yeah. And then you clean it up. What's negative 2x plus 4x?
2x.
2x, right? Minus 8. And then finally throw the negative 1 in there. Negative 1 over 2 times x squared is negative 1 over 2x squared. Negative 1 over 2 times 2x will be negative 2 over 2x. So that will be negative x or negative 1x. What's negative 1 over 2 times negative 8? Negative 1 over 2 times negative 8. Remember the
8
negative,
over 2.
yeah, the negative cancels out and 8 over 2 is a 4. So there you go. That's the equation. Final answer in standard form. Most of this is the same thing. What is this shape? Is it a rectangle?
No.
What is it? It starts with a T. It's a trapezoid, okay?
Mhm.
Trapezoid. In fact, this is something called an isosceles trapezoid because these 2 side lengths are equal as denoted by this line here. This is a trapezoid. How do you find the area of a trapezoid? It's a tricky formula. It's not that simple. I'll give it to you. A trapezoid has 2 sides, top and bottom. This is called A, this is called B, okay? Trapezoid also has a height component, which is this. 2x plus 2 is the height. The area of a trapezoid is equals to A plus B divided by 2 times the height. So here, what does it become? It becomes x plus 1, that's your a value, plus 3x plus 1, that's your b value. Divide that by 2, and times that by the height, which is 2x plus 2, like that. X, and again, now you're just collecting like terms in the first bracket. X plus 3x is 4x. And then you have 1 plus 1, which is 2. So you have 4x over 2 times 2x plus 2, like that. What is 4x plus 2 over 2? You can think of it as 4x over 2 plus 2 over 2. 4x over 2 plus 2 over 2. Because this denominator, you can distribute it. What is 4x divided by 2? It is 2x, okay? 4x over 2, look at this. 2 goes into 4 twice. 4x over 2 is 2x. What is 2 over 2?
1.
1. So you have 2x plus 1 times 2x plus 2, like that. Last thing we do is we FOIL it. What's 2x times 2x?
4x squared.
4x squared. The next term is 2x times 2, 4x. The next term is 1 times 2x, 2x. The last term is 1 times 2, 2. So therefore, the final answer to this question, 4x squared plus 6x plus 2 is the area of the trapezoid. Cool?
Mm-hmm.
It's a goofy figure here, trapezoid. This one is isosceles. The formula is exactly the same. So isosceles just means this side and this side are equal. But you can get like a non-isosceles trapezoid, something like this, where this side and this side are not equal, but the formula remains the same. You need the h component, which is the height. Height is always perpendicular to the base, starting from top to bottom. Top side is called A. The bottom side is called base or B. The area is A plus B divided by 2 times height. Area of a trapezoid. Cool?
Mm-hmm.
Let's do a more difficult question. It says expand and simplify. Now, if you want to save time, I'll give you something. This works for squares and cubes. Cubes we're not going to see for a while. Squares, here's a little formula that you can use. It'll save you some time over the years. If you have anything in this form, a plus b squared, this becomes a squared plus 2ab plus b squared. If you have anything in this form, a minus b squared, this becomes a squared minus 2ab plus b squared. The only difference here is this plus becomes a minus if you have a minus b squared. If you use this, you don't have to FOIL it, okay? You can save an extra step. You can always FOIL it. This one will save you an extra step. Let's try to do this using this equation. Can we throw the 2 in there, or do we need to square it first? Do we multiply by 2 first or square first?
You square first.
Yeah, bad mess. Exponent comes before multiplication. You have to square first. So 2 on the outside stays as it is, right? Now look at this. 3x is your a, b is 4. Okay, if you want to use this formula, 3x is your a, b is 4. What is 3x squared? In other words, 3x squared is, what's 3x times 3x?
9x squared.
9x squared. That'll be your first term. The next term is going to be, because this is a plus, this will be a plus. The next term will be 2 times 3x times 4. What is that? 2 times 3x times 4. 2ab. What does that simplify to?
24x.
Yeah, 24x. What's the last term? It's just b squared.
16.
16. Minus 3. I'm going to use the same formula here, but with a negative sign. This is a, this is b. What's a squared in this case?
X squared.
X squared. What's the next term? It'll be 2 times your a value times your b value, right? With a minus sign.
4x.
4x. What's the last term?
4.
4. There we go. See, if you use this, you don't have to FOIL it, and you don't have to collect like terms. See, it saves you a couple of steps there, yeah?
Mhm.
And over time, it'll save you a lot of time. And you can quickly do this in your head, especially if you're doing like if you ever give the SATs or something, you know, like college. Some universities require you to take an entrance, especially in the US. And those questions are timed, right? You need to maximize your efficiency, and stuff like this will save you crucial seconds that you need to answer every single question. Sometimes it's not possible to answer every single question. That's how they're designed. So efficiency is sometimes key. Now we have to FOIL it. 2 times 9x squared, 18x squared. 2 times 24x, 48x. 2 times 16, 32. What's the next term if you FOIL this? What's negative 3 times x squared?
Negative 3x squared.
Yeah. What's negative 3 times 4, negative 4x?
12x.
12x. What's negative 3 times positive 4?
Negative 12.
Negative 12. Now we collect like terms. So 18x squared minus 3x squared becomes 15x squared. 48x plus 12x becomes what? What's 48x plus 12x?
60x.
60x. And then finally you have 32 minus 12. What is that?
20.
That's it. That's the final answer. Alrighty. So we have the area of a rectangle, and then there's two possibilities Bill is claiming. Either it's the length and the width is the first two terms, or the length and the width is the next two terms. Yeah, they could both be possible because again, remember this, you just multiply the x's. So that makes sense that it's 2x squared. For the y-intercept at 20, right? You always multiply the constants together. So 4 times 5, 20, 10 times 2, 20. It does make sense. The only missing piece of the puzzle is the middle bit, the 14. Now for that, you have to check. So by check, I mean you have to FOIL it and see if you end up with a 14. That's the first possibility. This is the next possibility. Let's open the bracket. What do you get here? Open this bracket.
2x squared plus 10x.
Plus 4x plus 20, right? So this becomes 2x squared plus 14x plus 20. So that checks out. Let's try doing the same thing with this. 2x squared plus 4x plus 10x plus 20. Yeah, that one checks out as well. So therefore, both of these claims are valid, okay? They could both be the dimensions of the, what is this, rectangle? This is gonna be like a 4+ question. Question 15. So this kind of uses everything you've learned. Like I've always said, if they give you an equation, it's not that difficult because everything, if you can do a couple of them, you can do all of them. But if they give you something like this is a very interesting question. This one's gonna throw people off for sure. So we know there's a arc that is parabolic in shape. It is 88 meters high. It is 84 meters across. Determine a quadratic relation in standard form that models the shape. Any ideas on how to even approach this? What would you do if you saw this? Let me tell you, we have learned all the tools to solve this question. The first part is the most difficult, which is coming up with the equation. Think about what the graph of this looks like, okay? I would start this by drawing a graph. This is more of a modeling question. We know the height is 88, right?
Mhm.
What does that mean? That's gonna be, you see this? We know this
The
distance here
vertex.
is, yeah, we know the vertex is 88. So this point on the y-axis is 88. And we know it's 84 meters across at its base, right? So that means the distance from here to here is 84. What does that mean for us in our graph? You see, we started here. You
Mhm.
know, this distance is 84. So what have they given us?
The x-intercepts.
The x-intercepts, right? If we claim one of the x-intercepts to be 0, the other one must be 84. Yeah?
Mhm.
So that means what's the x value of the vertex? Remember, it's always going to be exactly in the middle.
42.
42. Therefore, we know that vertex, that is 42 comma 88, right? We have the vertex, we have the x-intercept. We can use either the factored form approach, or we can also use the vertex form approach. Both of them are equally as valid. If you use the factored form, what is your equation? Y equals A, right?
Mhm.
We know this is S, we know this is T. So x minus S becomes x minus 0, or just x. What's the other bracket? The other bracket was in factored form, it's x minus T.
X minus 84.
X minus 84. Next, we need to find the A value. How do you find the A value here? Is there any other point that we can use?
The vertex.
The vertex, definitely, right? But if you think about it, it goes through the origin. So if you want to be lazy about it, you can use 0, 0 as well. Vertex form works just fine, but I would use 0, 0 because I think it's more, the math will be a little bit easier. Do you agree with it? You see this?
Mhm.
If it goes through the origin, it's going to go through the 0, 0, the coordinate. So I'm going to use y as 0. You can always use 42, 88. They will both give you the exact same answer. A, yeah, times 0. Actually, this is not going to work out because you have to use the vertex. Look at this. A times 0 is 0, right?
Mhm.
So you get 0 equals 0. That doesn't help us. So no, that's a no-go. That coordinate is not going to help us. It's worth a try though. You have to use 88, 42. Otherwise you get 0 equals 0. It's because of this x. If this was x minus something, 0, 0 would have worked out, but because it's just x, it does not. So you have to use the vertex. So this becomes 88 is equals to a times 42 times 42 minus 84, yeah?
Mhm.
So this is gonna be a big number. 42 times 42 minus 84, 88 divided by that. So I get a weird number, it's okay. A is negative 0.05. And it makes sense that the a value is negative because this quadratic parabola is opening downwards. So therefore your equation is negative 0.05 x minus 84. The question is asking us to find it in standard form. To go to standard form, always open the brackets. X times x is x squared. X times negative 84 is negative 84x, and then finally multiply by negative 0.05, so you get negative 0.05 x squared plus, what's 84 times 0.05? 4.2 x. And there you go, that's the equation in standard form of this parabola, okay? Make sense?
Mhm.
When is this going to be useful? I guess this is things like these are most useful if you're trying to glide through it. Here, I'll give you a real life example. You heard of paragliding,
Uh-huh.
right? So maybe some daredevil wants to, paraglide through this arch. So he knows the wingspan of his glide, right? See, it looks something like this, right? A paraglide looks something like this, where you have a person like hanging, dangling through it. I've done it actually, it's very scary. So let's say the person knows his wingspan, right? And the
Mhm.
person also knows the length across here. And maybe he wants to go through right in the middle because that's when it's gonna be the most practical. So maybe he wants to go at it at 44 meters height. And if he can figure out this distance here, right? Which he can easily figure out because we know the axis of symmetry. And he knows his wingspan, he can make a deduction whether he's gonna fit through it or he's gonna crash into it. So that could be like a practical example. And people do this in real life. It's very scary. I would never go through that, but some people do. There's videos on YouTube about it. So that could be like a practical example or use of this question here. All right, let's call it a day there.
Okay, thank you.
All right, see ya.